This is going to start our next lesson looking at algebraic expressions and variables and just like a real basic overview of what we're going to get into further on with our expressions and equations. So you need to write this down somewhere in your notes so that you have these definitions. They should be in your book. This is coming from lesson 4 and 5, but we're not really looking at the book that much through this because we just don't have a ton of time to cover these materials. So make sure you have a piece of paper with you while you're going over this with us so that you can write down the notes and you can study later. All right. So one of the first words that I want us to know, and we've already talked about with our percentages, is the word variable. So hopefully you already understand that a variable is just a letter, and it's any letter of the alphabet that represents an unknown number. And our most common examples, especially when you're doing your graphing with the coordinate plane, would be the variable that is just a letter X. Or you could have Y. Like I said, it's any letter. I would stay away from the L and the O and S because they look like numbers. So for the most part, you're going to see X. You'll see N a lot, and Y, and B, also B. All right, so a constant is another word that I want you guys to write down and understand. So it's just a constant. The word would be like, I constantly have to do homework, basically, just constant, okay? This is a number that does not change. All right, and in an expression, it looks like, so for my example, it looks like, let's say X plus 5. Your constant there is the number that's by itself. It's not going to change in the expression. That's it. It'll be a 5. That's your constant. The next word is coefficient. This is the number that's being multiplied times the variable. So it's a number times the variable. Okay, in your example of that one, so it's a number that is multiplied times the variable. Your example would be, let's say 2x plus 5. We'll keep the plus 5 there. This 2 is your coefficient. So this one actually has all three of them. So your coefficient is the 2, your variable is the x, and your constant is the 5. Okay, so that's all three. If we talk about terms, so a term is going to be the different parts of your equation. So this is one term and this is another term. They're usually separated by plus and minus signs. Notice how the 2 times x is still just one term. Okay, so an example of an algebraic expression. So an example would be, let's say 150 plus y. That's an algebraic algebraic expression. Not an algebraic expression, so not an example. Okay, so non-example would be, let's say 85 divided by 5. It's not an example. It doesn't have a variable. It's just, that's just a regular old math problem, division problem. Okay? So in order to solve this or to evaluate for this, so let's write this out. And at any time that you have to pause this, feel free to pause it. I cannot pause it here and start back. So anytime you need to pause, just pause and then continue writing. So to evaluate or solve an algebraic expression, if I can spell it, you substitute a number, usually it's given to you. So you substitute a number for the variable, and then you find the value by simplifying. Oh, that is not how you're supposed to simplify. I'm sorry. Let me write that over. I got my Y and my F mixed up. My Y and my I. simplifying. This is why I teach math, sorry. All right, so kind of to go over that again, to kind of explain it. So to evaluate or solve, to find the answer basically to an algebraic expression, you have to substitute a number for the variable and then find the value by simplifying. Okay, so let's think about all these steps. So to answer it, you're going to substitute a number for the variable. Okay, think about in class, a substitute teacher is going to take the place, like if I'm sick, a substitute teacher will come teach you. Okay, it's taking that place. Okay, you're substituting, so you're changing out a number for the variable. So when you see this variable and you say, well, let's say for this example up here, 150 plus y. So if we say 150 plus y, what does this equal? So evaluate, we'll put evaluate right here. Evaluate 150 plus y when y equals, and let's say just an easy 10. Okay, so fairly simple here. So evaluate, to solve or to answer this, we're going to substitute this number for y, and it has to tell you the number and it has to tell you what it equals, what variable. Okay, so all I am doing is basically plugging in this value where I see any y's. There could be multiple y's. There's only one here. So I'm going to say 150 plus, and y equals 10. So I'm going to put 10 there. So it's now just a very simple addition problem. So then find the value by simplifying. Okay, I'm just going to simplify by putting these two together. They're like terms. Okay, so I can easily add the two numbers. So 160 is the answer to this algebraic expression. Okay, so to evaluate or to solve the problem, to work it out, you're going to substitute the number they give you for any of the variables. Okay, so if it has y and y equals 10, and you go back to see where you have y's or just one y, plug in the 10 and then work it like it's written. Okay, notice how I didn't change the plus sign, it's still a plus sign. Okay, so we have some example problems, and I went ahead and wrote them down on this paper. So we're going to evaluate each expression, and it tells you what we're going to be working here. Okay, so I have one variable and I have it dividing by 11. When w equals 55, what would this one equal? Okay, so I'm going to take my number and I'm going to substitute it where I see the w. So w equals 55 here, so I'm going to plug in a 55 for w. So I'm just going to put 55 divided by 11. It's pretty important, really, that you guys just write it like this before just looking at it and say, okay, let me just solve that. Go ahead and write it down like the first step. So you're just plugging in the number. I'm not trying to solve anything, simplify anything. So just like you just plugged it in, write that down so you can see those steps. All right, then all I have to do is solve it. 55 divided by 11, well, that is just 5. Okay? Same thing with the number 66. If w equals 66, what does this expression equal? Well, plug in 66 for w, and then it becomes a simple division problem. 66 divided by 11 is just 6. 77, w equals 77. All right, 77 divided by 11 is 7. Okay, now you'll come to the part B, and this one's a little bit more challenging. Okay, so I have these are what n equals, and I'm going to work this out. I'm not going to do this exponent just yet, so just ignore that right now because we're going to talk about exponents in your technically lesson 5. So we're just going to ignore that for right now. All right, so what I'm doing here is I'm still going to write out my equation or my expression, and all I'm going to do is plug in where I see an n, I'll plug in the 1. Okay, so I'm not working it out yet. I'm just going to say 4 times 1, and then I'm going to add 6, okay? Now, according to order of operations, I have to do the higher order of operation first, so I need to multiply first. Okay, so 4 times 1 is 4, plus 6 is 10. Okay, so I multiply before I added. Okay, the next one, again, I'm just going to write it down with my 2 in the place of n. So 4 times 2 plus 6. Well, 4 times 2 is 8. Add that to 6 and you get 14. Make sure that you are multiplying first. Okay, again, now n equals 3, so we're going to say 4 times 3 plus 6. I have to do the 4 times 3 first. 4 times 3 is 12, plus 6 is 18. Okay, hopefully pretty simple. All you're doing is, it's very simple after you plug them in. They're not hard math problems. You do kind of need to know your order of operations here. So you're going to do all of your parentheses and exponent, parentheses first, and then your exponents. Then you're going to multiply and divide together from left to right, and then you'll do adding and subtracting together from left to right. Okay, so it kind of, if you wanted to write it out, it's an old thing called PEMDAS. And I know I wrote it sort of weird, you might remember it being PEMDAS, but you do parentheses first, you do exponents next, and then you do multiplying and dividing as sort of the same step from left to right. Same thing with adding and subtracting from left to right. Okay, so it doesn't necessarily mean that you have to multiply first. You have to multiply or divide left to right in the same step. All right, so then we're evaluating with two variables. Move that up a little bit more. So I have two variables here. It does not make any difference of what we just did. All I'm going to do is plug in my numbers. I'm just going to be plugging in two numbers now. That's it. So my x equals 4 times my y that equals 2. Notice this little circle right here, this little dot. I made it kind of big right here so that I can emphasize it's not a decimal. That is a multiplication sign. And I'll tell you why we do it like that, because this x, it would look weird if I said, well, we're saying x times w. That looks weird. We don't do that anymore. It just looks like you've got three variables that you're multiplying together. So what you would do instead, so don't put that, you would do instead x times w. Okay? Or you could just put them next to each other, and we know that variables that are next to numbers or variables that are next to variables are just being multiplied. Okay, and then 4 times 2, it's just a simple 8. We have 5 for x, times 2 is just 10. 6 for x, 3 for y. 6 times 3 is just 18. Okay, hopefully that's pretty simple. All you're doing is, like I said, you're looking at where the variable is the number, and then plug it in for where you see that variable. Let's see, I do have the back of this part too to go over. So writing your phrases as numerical or algebraic expressions. So we're going from words to your actual equations. So in this book, we got a good book here that I want to show. I should have pulled this out already. Let me go back. In this red book, it's not in your book, so if you need to pause it when I get to it, it's right around, it's a little bit too far. Like I said, I can't pause it or else it's going to stop, so you have to bear with me for a second. I think it's a little bit further back. There we go, we're getting to it now. All right, so would it helped if I had gone back and looked at that page? Sorry. Okay, here it is. You have this. Sorry about that, y'all. All right, so you have this nice chart right here. If I were you, if you're looking at like on a phone or something, maybe screenshot it. If not, look at the time that it's on. It's at 13:39 right now. So come back and look at this for sure. It's a very good tool for you guys to look at. So it's got the numerical expression, what you would see like on a math problem, and then it's got the words that you might see actually notated here. So it could be said 28 added to 37, 37 plus 28, the sum of 37 and 28, or 28 more than 37. And it has all of these, and it kind of shows you your algebraic expressions as well. So these are all numbers, and whenever we get to our algebraic expressions where we start putting an unknown, that variable in there, you can see it's still using the same words. 28 added to x. Well, 28 added to 37. We just don't have that known there. So it's the same words that you need to be familiar with and understand what it looks like, especially when you have these word problems that's going to say, hey, this number was the sum of these two numbers, and then their product of something, or it was the quotient of something. So you do have to understand these words and what they mean in your math problems. So like I said, this is a really good thing for you to look at if you can like take a picture on your phone or write it down if you want to. Just make sure that you come back and look at it and visit it for a little bit. And the reason I say that is because now we're going to write phrases as numerical or algebraic expressions. And you see I have those words here, and I don't have an expression, so I have to look at what the wording is. So first of all, fairly simple hopefully, 279 minus 125. Well, our minus here is going to be, and it's actually not even one of the special, well, it is right here. I was going to say it's really not even a special word because minus means difference, but right here we know that we are subtracting. So all I'm going to do is write 279 minus 125. You do also have to look at the order. With subtracting, especially if I had changed that and I said instead of 90 minus 12, if I said 12 minus 90, I would have ended up with a negative number. So please make sure of the order. Like this, for example, the 12 less than 90. Notice how 12 comes first. 12 less than 90 is a little bit backwards from what you would say. Okay. So the product of 15 and x, well, we can look in our little table. Product means to multiply. So 15 times x. And again, you probably don't want to put 15xx, so it looks like you're multiplying variables together. Okay. The sum of 9 and q. So sum is the answer to an addition problem. So 9 plus q. P divided by 5. So P divided by 5, P would go first. Division is also so the subtraction and division are the ones that you're going to have to look at the order for. And then I did put this one on down here for you guys for sure to look at. 5 less than t is t minus 5. And again, I know that looks weird, it's backwards, but that is how that's written, and you will have that question. I guarantee you're going to have that question at some point, whether it be on this quiz, another quiz, on the state test. You will have that somewhere because they know that you're going to switch them up. And the reason it's like that, so if I said 5 less than, let's say 10, just to make it a little bit easier to look at with numbers, 5 less than 10 means 10 minus 5, because 5 less than 10 would be 5. So if you ever look at this and you say, well, I don't understand it with the variable, plug in a number. Say 5 less than 20. Well, if I say 5 less than 20, in your mind, even though this looks weird, you should say, okay, well, I'm taking 20 and I'm subtracting 5 from it. So even though it looks weird with a variable, plug in a number on your own and say, okay, well, what makes sense? And that might help you out there. So anyway, so this is your algebraic expressions. Kind of tells you your 3 main vocabulary words. There's more vocabulary words that you will see on the paper that has been shared. But these are 3 of the main ones for this lesson. Your algebraic expressions include letters or variables. And then to evaluate them or solve them, remember you have to substitute in that number that they give you for the variable. And then you find that answer by, they say simplifying, but really all you have to do is plug it in and work it out, really. Don't think about the simplifying too much, because I know we think simplifying means fractions. But you're just plugging it in and working it out, basically. And then again, that phrase, I'll show it again. This is a very good tool for you guys to use, so save this in some way. I don't expect you to write it all down, but if you're watching this, maybe screenshot it and look at it at some point.